show that 1 over 1 plus x to the power of n plus 1 over 1 plus x to the power of minus n simplifies to a constant. So we don't want any variables involved, we don't want any x's. And we're going to use some of our indices laws to help us work this question out. So the first thing that I'm going to do is I'm going to change x to the power of minus n in my denominator to 1 over x to the power of positive n. And I used law 5 to help me with this. So I said x to the power of minus n changes to 1 over x to the power of positive n. The next thing I'm going to do is I'm going to multiply my fraction on the right by x to the power of n divided by x to the power of n. So I'm going to do top by top, bottom by bottom. The reason that I'm going to do this is I want to, first of all, get rid of this in my denominator, but ultimately I want my denominator on the right to match with my denominator on the left so that I can get a common denominator. Now if I multiply 1 over x to the power of n by x to the power of n, what I'm doing is I'm multiplying it by its reciprocal. So x to the power of n is the reciprocal of 1 over x to the power of n. And when I multiply a fraction by its reciprocal, I end up getting 1. And that's what I want. Now with fractions, we can simplify them, or we can multiply the top and the bottom by whatever we want, so long as what we do to the top, we do to the bottom, what we do to the bottom, we do to the top. So if I'm going to multiply the denominator of this fraction by x to the power of n, I must multiply the numerator of this fraction by x to the power of n also, because x to the power of n divided by x to the power of n is equal to 1. So technically you're not changing the value of the fraction. Okay, so I'm going to start multiplying. 1 multiplied by x to the power of n is going to give me x to the power of n. And 1 over x to the power of n multiplied by x to the power of n is going to give me 1. So now my left fraction's denominator is 1 plus x to the power of n, and my right fraction's denominator is x to the power of n plus 1, so they're matching, and now we have a common denominator. But we must also multiply my numerators. So 1 multiplied by x to the power of n gives me x to the power of n. Now that I have a common denominator, all I have to do is add my numerators together. So 1 plus x to the power of n just gives me 1 plus x to the power of n. And my denominator from both of these fractions, my common denominator was 1 over 1 plus x to the power of n. So now I have 1 plus x to the power of n divided by 1 plus x to the power of n, and anything divided by itself is 1, and this is a constant. So this has been simplified to a constant.